derivative. We know how to take the derivative of function if we apply derivative operator to x squared and you will get 2x. And I also apply derivative operator to x squared plus 1 and you will get 2x too. And I also apply derivative operator to x squared plus pi and you will get 2x because the derivative of x squared with respect to x is 2x and the derivative of pi with respect to x is 0 because pi is a constant. In general, we can say when you derive x squared plus c or any constant, we will get 2x because derivative of x squared with respect to x is 2x and derivative of any constant with respect to x is 0. We apply derivative operator to any expression here and you will get 2x. Now let's go to another way around. That's still about antiderivative. Antiderivative is we are doing the opposite of derivative operator. The derivative operator, you get the expression and you will find the derivative. Now we want to do is you given a sum expression and you will find what could derivative of. Like someone will ask you what is 2x the derivative of, which means what is the antiderivative of 2x. Well, you can say x squared is antiderivative to 2x, or x squared plus 1 is antiderivative of 2x, or x squared plus pi is antiderivative of 2x. So you can write, in the most general sense, you will write 2x is antiderivative of x squared plus any constant, or c. This is, you can consider as the antiderivative of 2x. So we will write a long elongated and dx along the function that you want to solve, which is 2x, and the answer is x squared plus c. This expression we also call as indefinite integral of 2x, or we can say as an antiderivative of. This is very useful when you want to know the area under the curve, or we study about the definite integral. Okay, let's move to the basic rules of integration. As you can see, this is an example, or this is the basic rules of integration. The first one is multiplication by constant, power rules, sum rules, difference rules, integration by parts, and substitution rules. For the multiplication by constant, as you can see, you have a constant in your function. So you need to take off the constant and you just integrate your function. For power rules, this is this formula. For example, you have x power of n and you integrate it, you will get x power of n plus 1 times n plus 1 plus c. For sum and difference rules is the same because you just need to split the function into two. The first, for the example, you have two functions, which is f plus g, and you just to split into two. The first one is you need to integrate what is the integration of f plus what is the integration of g. For integration by parts, for example, what is the integration of x multiplied by cos x? Okay, we have x multiplied by cos x, so the integration by part is a good choice. First choice, which function for u and v. Okay, let's say we take u x in terms of u and cos x in terms of v. So now it is the format. You can see x in terms of u and cos x in terms of v. The first step is you need to differentiate u. We know u is x, so when we differentiate x, we will get 1. The second step is you need to integrate v. When you integrate cos x, we will get sin x. And now we can put it together. You can see the first one is u times v prime minus integration of u prime times v prime. For substitution rules, for example, you get the integration of cos x squared times 2x. We know from above that this is the right form to do for substitution. The first one is you need to let x squared in terms of u and 2x dx in terms of du, because when you differentiate x squared, you will get 2x. Now you need to integrate. When you integrate cos u, you will get sin u plus c. And finally, you put x squared back again because you just let u x squared in terms of u. So this is the answer.
For integration exponent function, example 1 is integrate of exponent x dx will be exponent x plus c. For second example, integrate exponent ax dx will be 1 over a times e exponent ax. The answer will be exponent ax over a plus c. For natural logarithm function is integrate 1 over x dx will be ln x plus c. For integrate f prime x over fx dx, I take example of integrate 3 over 3x minus 5 dx. We let u is 3x over 3x minus 5 and du will be 3 dx. Integrate 1 over u times du will be ln u plus c. We substitute u will be ln 3x minus 5 plus c.
Okay, today we're gonna learn about integration of trigonometric function. Okay, as you know that we have a formula for integration, which is you can see here. You have to memorize it if you want to do such as example. So memorize it. So here the first example. So we got integration of cos ax dx. So if we want to integrate, we have to let u equals to ax. So du equals to a dx and dx is equals to du over a. So from here you have to substitute ax with u and dx with du over dA. So we got 1 over a integrate of cos u multiply with du. So we got 1 over a sine u and we substitute back u with ax. So we got 1 over a sine ax plus c. So we move to second example. Second example shown that integration of sine ax dx. So we have to let u equals to ax, du equals to a dx and dx is equals to du over a. So from here we have to substitute with ax with u and dx with du over a. So we got this 1 over a integrate sine u du. So we got 1 over a negative cos u and negative 1 over a cos ax plus c. We move to third example. Third example shows we move to example 5, which is integration of tangent square x secant square x dx. So we let tangent square x is equals to u square and secant square x is equals to du. So let u equals to tangent x, then integration u square du and we got 1 over 3 u cube plus c. So we substitute u with tangent x, so we got 1 over 3 tangent cube x plus c. We move to last example, which is integration of cosecant x cotangent x dx. So we let u equals to sine x, du over dx is equal to cos x and du is equal to cos x dx. So from here we got integration of 1 over sine x cos x over sine x dx. Integrate with cos x over sine square x dx, which is cos x dx is equals to du. So integration 1 over u squared du, we got negative 1 over u plus c. So we substitute u with sine x and we got negative 1 over sine x plus c. So we simplify it with negative cosecant x plus c. We move to example 4, which is integration cosecant square x dx. So we let u equals to cotangent x, which is equals to cosecant x over sine x. So we got du is equals to negative sine x multiplied with sine x minus cos x and multiply with cos x over sine square x dx. So we simplify this and we got negative sine square x plus cos square x over sine square x dx. So du is equals to negative 1 over sine square x dx. So we substitute du in this equation. We got negative 1 over sine square x dx, and we got negative integration of du. So integrate this, we got negative u. So we substitute u with negative cotangent x plus c.
Okay, for the last subtopic in chapter 5 integration, we will learn about the evaluating definite integrals by substitution. It has evaluation step that we need to do in this subtopic. It was method 1 and method 2. Then let's take a look for the exercise in this subtopic. Then for the exercise, we will do the first method. It was integration 5(1) 2x minus 5 cube dx. Then we will let u. It will be du dx equal to 2 and dx equal to 1 over 2 du. We rewrite back the question. It will be, we replace it with u. It will be u cubed times 1 over 2 du. And then we integrate. Then we will substitute x into x. And then we will get the answer. It was 68. Okay, for the second method, we use the same question. So for the question, we will let u, same with the first method. Then we got dx equal to 1 over 2 du. So we rewrite back. It will be integrate u cubed times 1 over 2 du. And then we will integrate it. Then we will calculate the value of u with substitute the number of x 1 and 5, and then we will got the value of u. So the value of u we can substitute into the u. So we will get the same answer as the first method.